Welcome to Foundation Mathematics, Essential Background 1, Like Terms, Brackets, Fractions, Highest Common Factor, and Factorizing. The objectives for this session are to simplify algebraic expressions, expand brackets, add, subtract, multiply, and divide fractions, manipulate and factorize algebraic expressions, recognize that factorisation is the reverse of expanded expressions, and find the highest common factor of algebraic expressions. We can simplify algebraic expressions by collecting together like terms. Pause the video and have a go at this example. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to simplify the expression shown on your screen. So let's solve this. First, put the like terms together. So the m squared n terms go together, the mn cubed terms go together, and similarly for the mn squared term. This makes it easier to add up the terms, as shown. Again, put the like terms together, the x squared terms, the x terms, the constant terms, and the x cubed term. It is conventional to position the highest power first and then go down in order of size. So 4x minus 2x is 2x, and the constant term simplifies to minus 2. Now let's have a go at another example. We are required to simplify 30x squared divided by 2x. So let's solve this. We have that 30x squared over 2x equals 2 times 15 times x squared divided by 2x. The 2's can cancel, and similarly the x's can cancel, to leave us with 15x. Let's now have a go at another example. We are required to expand 7 times x plus 3. So let's solve this. Multiply each term in the bracket by the term outside. So 7 times x is 7x, and 7 times 3 is 21. And now for another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Again, we're required to expand the expression shown on your screen. We therefore multiply each term in the bracket by the term outside. And so 2 times 8 is 16. 2 times minus x is minus 2x. And here we've expanded the expression. And now for another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Again, we're required to expand an expression. So multiply each term in the bracket by the term outside. We have 7 times 8y is 56y, and 7 times minus 3x is minus 21x. We will now look at how to expand brackets. To find the product of two expressions inside brackets, you must multiply each term in one expression by each term in the other. Let's now give some examples. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. So let's take a look at part A first. We are required to expand x plus 1 times x plus 3. So x times x is x squared, x times 3, 1 times x, and 1 times 3. So all the terms have been added together. Now we tidy up. So x squared remains as it is. 3x plus x is 4x. And 3 also remains as it is. And now for part B. We are required to expand x minus 3y times 2x squared plus 5. X times 2x squared, x times 5, minus 3y times plus 2x squared, and finally minus 3y times 5. We interchange the terms to obtain decreasing powers of x as shown. And now for part C. We are required to expand x minus y times x plus y. X times x, x times y, minus y times x, and minus y times y. We tidy up, so xy minus yx is actually 0. So we're left with x squared minus y squared. And now for part D. We are required to expand x minus y all squared. X times x, x times minus y times x, and minus y times minus y. Now let's tidy up the expression. Leave x squared as it is, as there's only one x squared term. Minus xy minus yx is minus 2xy. And finally leave y squared as it is. And now for part E. We are required to expand x plus y times 2x minus 3y minus 7. So x times 2x, x times minus 3y, x times minus 7, y times 2x, y times minus 3y, and y times minus 7. Now let's tidy up. Bring down 2x squared as it is. The xy's can be added together, so we have minus 3xy plus 2xy, giving us minus xy. There's only one x term. There's only one y squared term. And there's only one y term. So here's our expression. Algebraic fractions are similar to numeric fractions. They can be simplified by cancelling common factors and finding common denominators. To multiply fractions, cancel any common factors and then multiply the numerators and then the denominators. Let's take a look at an example. Simplify the expressions shown on your screen. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We are required to simplify 2 over 7 times 7 over 6. So let's solve this. This can be rewritten by cancelling the 7s as shown and by cancelling the 2 and the 6 to 1 and 3 as shown. And then multiplying gives 1 times 1 is 1 over 1 times 3 is 3. And now for part B. We can cancel the b's as shown, and we can leave the a and the d as they are as shown. Then multiply to give a times 1 is a over 1 times d is d. And now for part C. Let's first factorise what we can. We can't do anything here, and we can't do anything here. However, we can factorise x squared minus 1 to x plus 1 times x minus 1 as shown. And then we can cancel top and bottom the x minus 1's as shown. Then we have 1 over 4 times 5 over x plus 1. And then multiplying gives us 1 times 5 is 5 over 4 times x plus 1 as shown. Now let's take a look at another example. We are required to simplify the fractions shown on your screen. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. We have a over b divided by c over b. We therefore turn over the second fraction and multiply instead. So we have a over b times b over c. Next we cancel, as shown, the b's, and we leave a and c as they are. Then multiply across gives us a times 1 is a over 1 times c is c. And now for part B. We have one algebraic fraction divided by another. So we leave the first algebraic fraction as it is, and then turn the second one upside down and multiply. We then see if we can factorise further. We can leave x plus 3 over x minus 3 as it is, and factorise x squared minus 9 to give x plus 3 times x minus 3. And of course we leave 4x plus 1 as it is. We can cancel the x minus 3's as shown, and then multiply this fraction by this one. To give x plus 3 squared all over 4x plus 1 as shown. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. We begin with part A. So in order to add two fractions, we need to make sure that each fraction has a common denominator. So let's do that with our fractions. 2/5 is going to be multiplied top and bottom by 4. And 1/4 is going to be multiplied top and bottom by 5. This will then mean that our fractions that we are adding will have the same common denominator, which is in this example 20. So we have 8/20 plus 5/20. And then we can add to give 13/20. And now for part B. Again, we are adding two fractions, and this time we're adding algebraic fractions. Of course, to add or subtract two fractions, we need to find a common denominator. So let's solve this. The common denominator that we will have is 12x. So for the first fraction, a/3x, we multiply the numerator by 4 and the denominator by 4, as shown. And for the second fraction, we multiply both the numerator and the denominator by 3 to give 4a/12x plus 3b/12x. And this, of course, gives us 1/12x times 4a plus 3b. And now for part C. This time we're subtracting two fractions. However, we still need to find a common denominator. So let's solve this. We're going to multiply the first fraction in the numerator and the denominator by x minus 2. And the second fraction we're going to multiply top and bottom by x plus 5. So we now have a common denominator, x minus 2 times x plus 5. And now we can subtract, as shown. To give minus 7 over x minus 2 times x plus 5. And finally for part D. Again, we're subtracting two fractions, so we need to have both fractions sharing a common denominator. We can actually factorize the denominator of the second fraction. So we're going to leave the first fraction as it is for now, and the numerator of the second fraction as it is. And here's this denominator factorized, x plus 2 times x minus 2. So clearly, all we now need to do in order for both fractions to have a common denominator is for us to multiply the first fraction top and bottom by x plus 2, as shown here. Then we expand the brackets for the first fraction and then subtract 4 and put everything over the common denominator. And finally tidy up to give 2x over x plus 2 times x minus 2. Expressions can be written as a product of their factors. The opposite of expanding brackets is factorizing. So let's take a look at some examples. factorised expression is given on the left-hand side and the expanded expression on the right. So 2x times 7x in the brackets is 14x squared. Add 2x times 8y in the brackets is equal to 16xy. X plus 2 all cubed is as shown. And x plus 5y times x minus y is as shown. We will now look at how to factorise expressions, which is the reverse of expanding brackets. Pause the video and have a go at the examples on your screen. Press play when you are ready to view the solutions. So let's solve part A first. We are required to factorise 2x plus 8. Express each of the terms in the expression as factors and then find factors which are common to each term. 2x can be left as it is, and 8 can be expressed as 2 times 4. The value 2 is common to both terms, so we can factorise as shown. Now let's solve part B. We are required to factorise 2x squared minus 5x. 2x squared equals x times 2x. And 5x equals x times 5. Notice that we have positioned the factor x, which is common to both terms, at the start of each term to make it easier to factorise. And finally we can factorise. The factor x, common to both terms, goes outside the brackets, and the rest goes inside the brackets. We can factorise the expression in part C similarly in the following steps. You may notice that 6x is common to both terms, so we position that towards the front of each term. And likewise for the second term. So we position the 6x outside and the x plus 4 in the brackets. We will now factorise the expression in part D similarly. So 3xy is positioned at the start of each term because it's common to both terms, as you'll see. Here we have 12xy squared expressed as 3xy times 4y. Notice the 3 and the 4 which have been put in bold, when multiplied together give us 12. And now 3xy can be positioned outside the brackets and the rest inside. Let's finally factorise the expression in part E. Again, we consider each term separately and position the factor which is common to both terms towards the front of each term. So 2x squared is as shown, and minus 16xy is as shown. You can see that 2 and 8 have been highlighted as 2 times 8 is 16. So we position the 2x outside the brackets and the rest inside. We will now look at another example. Here we are required to write down the highest common factor of 18 and 30. So let's solve this. First express each number as a product of its prime factors. So 18 equals 2 times 9, which equals 2 times 3 times 3. And 30 equals 3 times 10, which is equal to 3 times 2 times 5. It is conventional to put the numbers in order of size. Now 18 and 30 have two factors, 2 and 3 in common only. Therefore, the highest common factor of 18 and 30 is 2 times 3, which equals 6. As shown. Now 3y and 6y squared have 3 and y in common only. Therefore, the highest common factor is 3 times y. We will now look at another example. Here, we are required to write the highest common factor of 7x squared y and 14xy squared. So let's solve this. Again, writing each expression as a product of its prime factors gives us that 7x squared y equals 7 times x times y. And 14xy squared equals 2 times 7 times x times y times y. Notice that these two expressions have 7x and y in common only. Therefore, the highest common factor of 7x squared y and 14xy squared is 7xy. This brings us to the end of this session. If you have understood its contents, you should be able to simplify algebraic expressions, expand brackets, add, subtract, multiply and divide fractions, manipulate and factorize algebraic expressions, recognize that factorization is the reverse of expanded expressions, and find the highest common factor of algebraic expressions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.